Let's practice sketching the reciprocal trig functions. So it's good to memorize what y equals sine, cos, and tan look like. And sine connects to cosecant, cos connects to secant, and tan connects to cotangent. It's very strange that the letter S and C are opposites. C for cos and S for secant, so please don't get tricked out. So the sine graph, we're focusing on cosecant right now. The sine graph, just draw 4 teeth. Sine goes up, down, down, and up. And it keeps on repeating as well. It keeps on repeating. But let's just focus on the first cycle here. 2 pi is the cycle, pi is the halfway point, and pi over 2 would be the first maximum of sine. So what I recommend you do is to draw some imaginary vertical asymptotes whenever sine is 0. And what's going to happen here to sketch cosecant is focus on the maximum. The maximum of sine is here. Cosecant is the same thing as 1 divided by sine x. So 1 divided by 1 remains 1. And so cosecant kisses the bump there and it curves up, respecting these vertical asymptotes at 0, pi, 2 pi, etc. And you can see there's a minimum here, and cosecant kisses that bump and respects these asymptotes. Let's focus on a small positive y value for sine. 1 divided by a small positive y value for sine, 1 divided by 0.001 is going to be very big, tending towards infinity, positive infinity. Whereas if it's a small negative number, 1 divided by a small negative number would tend towards negative infinity. So this is the way you can sketch the cosecant graph. Similarly, let's focus on secant. So secant, you can draw a cosine, pow, 2 pi, pow. You can even go towards the negative 2 pi direction. This is 0 in the center. Cosine starts at 1, goes down, and it goes like this. I'm just drawing a bit more than usual. And similarly, whenever there's a 0, you can just draw some imaginary vertical asymptote, vertical asymptote, vertical asymptote. And the secant graph would just kiss the bumps as well. So this here would be the secant graph. There's a minimum here, and the secant graph would be like this. So just to focus on secant, the domain of y equals secant x. You would say all real numbers, but remember there's vertical asymptotes. So I'm going to say x does not equals 2. Now this here is going to be 0, this here is going to be pi, and the first vertical asymptote appears to be pi over 2. So pi over 2 is a no-no, that's over here. But every 2 teeth, every 2 jumps, we have another problem. So 2 jumps is represented by pi units. So we're going to say plus pi n, where n is an integer. Integer is also known as the letter z. So you could say plus minus pi n, but n itself includes negative numbers. That's why I just write plus pi n. Now the range, normally sine and cosine of theta, or I can just say cosine of x as well, same thing, is normally between 1 and negative 1. But the range of secant, yes, it includes 1, but it's going to be everything other than what's up and down in the middle here. So we're talking about the range of secant of x. We're going to say y is greater than equals to 1, or y is less than equals to negative 1. Now let's focus on cotangent and tan. They're connected. You can see on here on decimals y equals tan x is this graph that shoots up with a vertical asymptote of pi over 2. If I type in y equals cotangent x, it looks kind of similar, but it's going down instead of shooting up. Now notice how y equals tan x, if I make it into f of x function, in order to hide this cotangent graph, Looks kind of similar. To get it, you could actually flip it twice. If I type in y equals negative f of x, yes, we know how to do a vertical transformation up and down. If I show you the cotangent graph, it's just shifted off a little bit, either left or right, pi over 2 units. So we just have to shift it a bit. So we're going to flip it and shift it by pi over 2. And when I say x minus pi over 2, that means shift it pi over 2 to the right. And if I flash hide the green and the blue graph, you can see they're on top of each other. So whether it be a plus or minus sign, left or right, it ends up being the graph. So the cotangent graph is actually a transformation of tan graph, flipping it and then shifting it.